Good morning. I'm Dr. E. Kavita, working as Assistant Professor in the Department of Chemical Engineering, SRM Institute of Science and Technology. I welcome you all for the video, Cleaner Technologies and Sustainability, Module 2. So in the previous video, I described about overview of cleaner production, assessment steps, and what are the skills required, and how to prepare for the site visit, information gathering, what is the role of process flow diagram, material balance. And in this video, I'm going to brief about waste reduction at the source. What are the practical techniques utilized for waste minimization, like good housekeeping, input material changes, product changes, technical changes, recycling. Let us move on to the video. Waste reduction at source. So what is waste reduction? So waste reduction at source, that is also known as pollution prevention, or it is a source reduction, which is a cornerstone of cleaner production. It focuses on preventing waste generation in the first place rather than managing the waste after it is created, like end of pipe solution. So this is the most preferred hierarchy in waste management. So these are all the essence of waste reduction. So pollution prevention, enhanced sustainability, cost reduction, and efficient usage of resources. So source reduction, so that is reducing the quantity and or toxicity of waste and emissions at their point of generation within a process, product, or service. So why source reduction is preferred? So source reduction is preferred due to economic benefits, environmental benefits, operational benefits, and also public image benefits. So what kind of economic benefits that can be attained through source reduction? So this reduces cost associated with the raw material purchase, waste treatment, disposal, and also regulatory compliances. Then environmental benefits. So it conserves the available natural resources, reduces the pollution load, and also it minimizes the environmental risk. Then operational benefits. So this improves the process efficiency. It also reduces the accidents and it enhances the product quality. Improved public image. It improves the process efficiency. Uh, by that, it improves the public image, like it demonstrates the environmental responsibility, and it boosts the brand reputation, and also it attracts the environmentally conscious consumers. So what is the core principle of source reduction? That is, it addresses the root cause of any waste, but not just the symptoms. So it is a proactive approach which finds the source of waste. Based on that, it modifies the process to reduce the waste in order to achieve the sustainable operations. Waste minimization. So this techniques, it's also like a strategy employed to achieve waste reduction at the source of generation. So in this upcoming slides, I'm going to brief about what are all the practical techniques involved in reducing the waste at the source of generation, and also how to optimize the resource use across different operations. So what are all the practical techniques for waste minimization? Good housekeeping, input material changes, product changes, technical changes, and recycling. So good housekeeping, often the simplest and most cost-effective cleaner production option. Then input material changes. So this involves like using the materials in a process in such a way that to reduce the waste or to improve the environment. performance. And product changes, so modifying the product itself to minimize the environmental impact. That is the eco design principle. That is the core structure of product change. Then technical changes, altering the production process or equipment in order to improve the efficiency and also reduce the waste generation. Recycling, it can be on-site or off-site recovery. So how are we going to recover the waste which is generated in order to reduce the consumption of resources and also reduce the environmental impact? So one by one, little bit brief. Let's see. Good housekeeping. So as I mentioned, so good housekeeping is often the simplest but also the most effective cleaner production option. Good housekeeping involves improving the operational and also managerial practices. So implementing systematic practices and disciplined practices to prevent leaks, any spillage of material or contamination, and inefficient use of resources. And also it involves inventory management, so implementing first in, first out in order to prevent material expiration, optimizing the storage conditions, reducing the excessive inventory, then optimized material handling, that is minimizing the transfer and also preventing spillage during loading or unloading or handling the material using appropriate equipments. Preventive maintenance. So regular maintenance of equipment in order to prevent breakdowns, leaks, and also inefficient operation. Then process optimization, it ensures the operation so that runs at optimal parameters in order to maximize the yield and minimize the waste. Then employee training and awareness, educating and motivating the employees on the importance of waste minimization, proper operational procedures, and also spill response. Then segregation of waste, it's like separating different waste streams at the source to facilitate reuse or recycling. Then proper labeling, so clearly labeling containers to prevent misuse or mixing of materials. Then cleanliness and organization, so that is maintaining a clean and organized work environment to easily spot any kind of issues and to prevent the contamination. So these are all the techniques involved in good housekeeping. The next strategy, input material changes. So modifying the raw materials used in the process to reduce the waste and also to improve the environmental performance. So substitution with less hazardous and toxic materials, like replacing volatile organic compounds with water-based solvents or hazardous pigments with non-toxic alternatives. Then use of renewable or bio-based materials. So switching from petroleum-based plastics to bioplastics, or using some green solvents instead of conventional solvents. Then using high purity materials, like reducing impurities can prevent side reactions and also a generation of undesirable byproducts or any waste material. Using recycled content or incorporating recycled materials. So incorporating recycled materials as inputs where feasible and also reducing the demand for virgin resources. Then packaging, changing packaging of inputs, like selecting inputs delivered in reusable or recyclable containers to reduce the packaging waste. So these are all the strategies involved under input material changes. Then product changes or a product modification or redesigning the product. So modifying the product itself to minimize the environmental impacts throughout its entire life cycle from design stage to disposal part. So this is also known as design for environment or eco design. So what are all the techniques involved in that? So designing for durability and longevity. So creating the products that last longer, reducing the frequency of replacement, and thus we can reduce the consumption of overall resources. Then designing for recyclability and disassembly, making products easy to disassemble into their constituent materials, facilitating recycle and also recovery at end of life. Then reducing material intensity, so designing products that use less material while maintaining performance. Eliminating toxic components. It also involves eliminating toxic components, removing hazardous substances from the product formulation. Then increasing the recycled content in the product, like manufacturing products using a higher percentage of post-consumer or post-industrial recycled materials. Then designing for reusability, so creating products or packaging that can be reused multiple times, and concentrating products which reduces water content in liquid products to decrease the packaging and also transportation impacts. And finally, modular design, designing the products with interchangeable modules, allowing for easier repair and upgradation rather than full replacement of the material. So these are all the strategies involved under product changes. Then technical changes, I mean process modification. So altering the production process or equipment to improve the efficiency and at the same time to reduce the waste generation. So technical changes that involves process optimization, equipment modification, cleaner application of cleaner technologies, and altering production processes. So process optimization, it's adjusting the operational parameters like temperature, pressure, flow rate, time taken to maximize the yield and also minimize the side products and reduce the energy consumption. And equipment modification or upgradation, installing a more efficient machineries like energy efficient motors, better insulation material, and implementing precision dispensing systems in order to reduce the material waste. Then using advanced control systems to maintain optimal conditions, installing closed loop systems to recover and reuse the process fluids or waste streams. Then cleaner technology, so it involves fundamentally inherent, that is reordering the process steps to improve the efficiency and also to reduce the waste. Then implementing water efficient cleaning systems, like counter current rinsing or dry processing alternatives, or improving the catalyst like using more selective or long lasting catalyst to reduce unwanted side products and also extend the catalyst life. So these are all the components involved in technical changes. Next, we'll move on to recycling. So in the under recycling, we have two components. One is on-site recovery, another one is off-site recovery. So while source reduction is preferred, recycling and recovery are important components of a comprehensive cleaner production strategy, and waste cannot be entirely prevented. So what are the components involved under on-site recovery? So it involves a lower operational cost. It ensures the material quality. It reduces the transportation cost. It uh, I mean it collects the waste from various sources. So materials are treated in order to prepare for reuse. Processed materials are used again in the production. So what are the examples which can be taken as an on-site recovery? For example, like collecting and filtering spent solvents for reuse in cleaning or as a raw material. Then recycling, for example, recycling instead of the solvent, we can also take recycling of cooling water in a closed loop system. Then reusing rejected product or off specification batches as raw material in subsequent production runs. Then recovering heat from exhaust gases for process heating, then on-site composting of organic waste. So these are certain examples for on-site recovery. Off-site recovery, so it is waste materials are collected and transported to external facility for processing and recycling. So the advantages of using offsite recovery are like it does not require any significant capital investment, and also the access to specialized recycling technology that is possible, and also it can handle large volume and also wide variety of waste components, and it is the only viable option for certain complex or hazardous materials. So that is what, as I mentioned, like so it manages waste, any complex waste, and it does not require much capital investment, and huge volume can be handled, and easy access to expertise. And offsite recovery, certain examples for that. So some sending some waste material like waste paper, plastics, or metals to commercial recyclers, contracting with specialized companies for solvent distillation and also for the recovery, then sending hazardous waste for treatment and resource recovery at offsite facilities. So using waste to energy plants for energy recovery from non-recyclable waste. And so transportation logistics, cost, regulatory compliance for hazardous waste transport, ensuring the ensuring the environmental performance of the offsite recycler. So these are all certain examples for offsite recovery. So with this, I'm completing module 2. Thank you all for listening. Thank you.